So, half pa lang ng class, no, yung dito sa session. So, open na muna natin yung camera para sa attendance natin, no, bago tayo mag-start. Para lang din makita ko kung sino yung mga latecomers, no, dito sa session.
Wait lang. Antay ko muna siya. Wait lang. Yung damit ko nga, gaganto ko naman. Saan ako? Diyan sa damit.
Okay, wait lang. Okay, one. Mas na iba. 1, 2, set pa.
Hindi screenshot pa ng mga present.
Si Dawati, nasa ano pa, sa ibang bansa ata siya. Parang hindi nasira ang micropipette last time ng 211. No.
Provide lang walang reason.
Parang wala tayong nasirang yung halagang 8,000.
Alam, miss, hindi ako nakakasira noon.
Wala na mga amin, no?
Ma'am Marcolita, present po. Baka po di ako na-picturean. Alay, ko balik ko mo, babe.
Picturean kita solo. Ngiti. Sige. Anyway, so saglit lang naman yung meeting natin ngayon, no? Since protein lang yung i-discuss natin. And sa Tuesday, no, yung ating face-to-face, sabihin ko na, no, ang tawag dito, ang kulang na lang po natin is the sodium and potassium, yung electrolytes, no? When it comes to laboratory activity. Pero dun sa ating yung natitirang topics natin, CREA BUN, after this meeting, no, CREA BUN and the electrolytes. So, onti na lang naman na. Kaya po, bago mag-final examination, ito si Reyes, pag to walang pasalubong sa akin, no? Galing siyang ang sibuyas na yun si Reyes, tignan niyo sa Tuesday. Tawag dito. Amoy sibuyas ka na. Tawag dito. Sa Tuesday, ayun nga. So, after natin ng discussion, magkakaroon po tayo ng para siyang peer review, no? So, ang mangyayari, no, i-distribute po ng maayos, Reyes, yung groupings natin. So, kunyari, 5 students lang per group, no? Hindi tayo per table. So, by group siya. Ang gagawin po natin, magkakaroon tayo ng review, no? Dahil alam niyo naman po kapag final examination, ang coverage po nun ay both midterms and finals, no? So, cover to cover siya. So, para makatulong po, no, ako sa inyo, magkakaroon tayo ng group review na graded po, no? And merong incentives kung sino yung mananalo. It's like parang quiz bee, parang ganun. No? So, bigyan mo ko, Reyes, ng list, no? 5 students per group. Okay? So, umpisahan nyo na din. Hindi ko pa kikialaman po, no, yung sa groupings ninyo. Basta gusto ko, may listahan lang na nasa akin. Okay? And then, pwede nyo nang umpisahan yung pagre-review. Dahil yung mananalo dun sa ating contest, yung mananalo, no, or yung pinaka madaming masasagot din sa ating gagawin, ay magkakaroon ng incentives po sa inyong final examination. Okay? So, to help you din, guys, na makakapag-review na, no, ng para at least mas madali na tayong makakasagot sa ating final examination. So, compre yun, ha? Compre ang ating final exam. Okay? So, sige. Pwede nang i-off ang inyong camera, no? Yes. Raymar.
Miss, I have a question po about sa moving exam. Meron po moving exam and ano pong contents po nun, if ever?
For moving exam, meron pa akong 2 weeks para mag-isip, no? Kung magpapa-moving exam pa ako. Pero, gusto niyo ba na may moving exam pa? Ha? So,
Opo.
if ayaw po. Si Dawat.
Wala na po.
Si
Wala na
Dawat.
po.
Tsaka si Chan, no? Ayaw na ayaw.
Wala po, Miss.
So, yun. So, iniisip ko pa kung magpapa-moving exam pa ako since yun nga yung parang gusto ko, alam mo yung makakatulong na sa inyo para ma-review kayo. No? Yun, so, tignan natin, no? Meron pa naman tayong ilang weeks. Ayun. So, gusto ko lang malaman na yung groupings ninyo para at least makakapag-start na kayo mag-review, no? As a group. Okay? So, yun. Let's start, no? Sa ating discussion. Maikli lang to since protein determination lang naman tayo. Okay, guys. Meron din pala akong isisingit pa, no? Na isang, hindi naman siya concern, pero at least lang din aware kayo, no? So, di ba, lagi kong nire-remind, hindi ako nagpapa-recording, hindi ako, kung hindi kailangan, no, hindi ako nagre-recorded lecture. Okay? So, kapag hindi recorded lecture, lagi ko sinasabi sa inyo na hindi ako nagre-record, no, ng session. Kung hindi kailangan. Ngayon, in general ito, no, not specifically sa inyong section or kung sino man nasa inyo, or kung meron man sa section ninyo. Pero meron sa aking mga report din na hindi, parang paano to, nagre-record ata siya nagre-record sila, no, sabihin natin, ng lecture ko, and voice recording, no, pagka naman face-to-face classes. Ngayon, sasabihin ko lang din naman sa inyo, no, na kung hindi ako aware na meron kayong ganong mga activities, like yun nga, parang nire-record nyo, nag-voice record kayo sa discussion ko, sa klase ko, meron pong grounds yun. Bakit? Kasi walang permission ko. So, hindi po sana masama na magbigay kayo ng notes sa ibang section or sa ibang kaklase ninyo na hindi naka-attend ng class. Okay lang yun. Walang problema doon. Open din ang aking PowerPoint kung meron, 'di ba? So open 'yan. Pero ang sa akin kasi, gusto ko lang din nakikita yung effort ng mga students na mag-aral. Hindi lang umasa sa recording, no? Gusto ko na, alam mo 'yun, na nagigets niyo ba ako, yung effort ang gusto kong makita. And to be fair din sa mga laging pumapasok sa klase ko. Laging pumapasok at nag-aaral. No, nagre-reflect naman yan sa sa quizzes ninyo, sa performance ninyo. Nagre-reflect yun. Nakikita ko yun kung sino po yung mga karapat-dapat, no, na pumasa sa section or sa subject, no, na to. So, ngayon, tulad nga ng sinabi ko, in general to, no, iwasan natin na, kasi parang for me, it's a form of cheating pa din. Kasi hindi ko alam yun no? Walang permission ko. And, yun nga, no? So, hindi ako aware na merong ganun. So, kung ang inaalala nyo, tulad niyan sila Reyes, galing siyang Cambodia, charot mo, galing siyang galing sa Malaysia, no? So, galing siya sa Malaysia, sino yung mga kasama mo, no?
Si Reyes Gracia po, tapos Bringas, Soriano, tsaka Santiso po.
O, diba? So, sila, excuse kayo So, hindi kayo dapat kabahan or yung ang tawag dito, yung parang hindi kayo dapat mangarag, parang ganun. Hindi ko alam kung anong tamang term, no? Yung gagamitin ko. Dun sa ating mga, kung may na-miss kayong activities or quizzes. Kasi hindi ko naman kayo isasabak, no, sa isang bagay na alam kong hindi kayo handa. So, iba po yung mga special activities ninyo. For example lang na may mga ganong excuse kayo dun eh. Diba? So, yun. Kaya po kung may mga, no, kung may mga nag-record, may nagbigay ng record, binigyan ng record, meron yan listahan sa akin. Okay? Kasi meron nang anong tawag doon? Whistleblower. Though hindi naman ako galit, no? Pero ini-explain ko lang kung bakit. Kasi para din fair, di ba, sa mga laging uma-attend sa klase natin. So, yun. Pwede pong lumapit sa akin at, no, umamin. So, hindi naman ako galit, pero at least lang, di ba? Kasi what if sa iba nyo gawin yon, i-record nyo, kahit sa inyo gawin ko, i-record ko kayo, di ba? Nang walang permission ninyo. Di ba? So, yun lang. At gusto ko kasi lagi, ayokong tawag dito, makakawala kayo, kunyari, dito sa CC, no? Hindi kayo dapat makawala sa CC ng walang natutunan. Kaya, yung adjustment din, tinitimbang ko din yan. Yung midterms, tas ngayong finals, lahat ng maitutulong ko parang may matandaan kayo, no? May pumasok sa utak ninyo, ginagawa ko. So, yun lang naman sa part ko. Okay? Kaya, yun po, no? Anyway, tama na ang sermon, no? At magkikita naman tayo sa Tuesday. Yan. So, let's start. Saan na tayo? So, for today's meeting, ang topic po natin ay protein determination. Protein. Ito lang. Check ko lang ha. Nakikita nyo na ba yung screen?
Yes po.
Okay, sige. And one more thing pala, no? Itong protein determination, no? Or protein reagent test kits, hindi siya available. So, nabanggit ko naman, no? Hindi siya available sa lab. Kaya hindi natin siya magagawa. Pero the procedure, no? Na gagawin natin dito para sa protein, same lang naman siya dun sa ating cholesterol and glucose, yung sa lipid profile natin, tapos yung sa creatinine. So, magkakaparehas lang sila, no? ng procedure. Kasi commercially prepared reagent test kits na po yung ginagamit natin. So, nagkataon lang na yung sa protein po ay hindi siya available. Okay? So, yun. So, let's start. For protein measurements, no? Unahin natin yung sample na ginagamit natin. So, lagi natin sinasabi for clinical chemistry, the usual sample, no, that we used is serum, no, rather than plasma. And fasting for proteins are not required, unlike dun sa ating cholesterol and lipid profile, no? Glucose, sorry. No? So, hindi siya hindi natin kailangan mag-fasting. Okay? So, interferences, no, in some methods occurs in the presence of, number 1, yung ating lipemia and yung hemolysis, no, sa ating sample. Kapag kasi sinabi nating lipemia or lipemic yung sample, anong ibig sabihin? So, the unusual high concentration of lipids or fats dun sa ating bloodstream, no? So, magre-reflect po iyan sa ating sample, no? So, may kita pa lang natin, yung sa sample pa lang natin kapag lipemic siya. Ang itsura po ng lipemic, no? Kung hindi pa kayo nakakakita, pero most likely, no, naka-encounter na kayo ng mga ganyang klase ng sample. Yung mga parang milky, upon blood collection pa lang may kita nyo, parang milky yung sample. So, possible cause po nun is yung ating high concentration of lipids, no? Sa bloodstream natin. So, lipemia, and of course, yung hemolysis, which is the ruptured RBC, no? So, ang nagkakos ng hemolysis. So, makikita naman natin sa sample natin is medyo pinkish na, no? To red yung ating serum. So, hemolysis, no, can cause falsely elevated ng total protein natin because of the release of RBC proteins. Okay? So, kaya magkakaroon siya ng false increase, no, dun sa ating result. For the reference interval ng ating serum total proteins, no, for ambulatory adults or yung mga when it comes to positioning, yung mga capable pa of walking, standing, yes.
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 False positive po, saan nga po ulit yun? Kasi hindi ko po nasundan.
Sorry. Falsely elevated, no? Or falsely increased.
Ako. Saan po banda yun sa lipemia or sa hemolysis po ba?
Sa hemolysis yun, no? Kasi,
Okay.
so bakit nagkakaroon ng falsely increased or elevated total protein concentration? Kasi pagka-hemolyze po yung inyong blood sample, nagre-release po siya ng mga RBC proteins. Okay, so andyan. Okay? Next. Nasaan na ba tayo? Ayun nga. Sa ambulatory adults, no? Yung mga positioning na parang capable of walking, standing, no? So, nakakagalaw pa ng maayos. Ang normal value po no, ng ating total protein is 6.5 to 8.3 grams per DL. Okay? Pagka naman kinonvert natin siya into grams per liter, syempre, 65 to 83 grams per liter. Okay? So, yan yung ating mga reference interval. For recumbent position, so pagka sinabi natin recumbent position, ito yung mga naka-recline at saka mga nakahiga, no? Lying position. So, ang normal value naman is 6 to 7.8 grams per DL. So, pagka kinonvert natin into grams per liter, 60 to 78 grams per liter. Okay? So, lower concentration, so total protein, okay, take note, has a lower concentration at birth, okay? But gradually, it increase, no? Pagka nag-age po tayo. So, 3 years old and above. So, nag-i-increase din yung ating total protein. And take note, no? Mababa din po ang ating protein kapag tayo ay buntis, no? So, during pregnancy. Okay? Bigla ko na. Okay. So, in the protein or in protein determination, we have several methods. So, first, we have the Kjeldahl method. So, this is a classic method for quantification of total protein, okay, which determines the nitrogen. Okay? So, this nitrogen can be measured, no, in both organic, okay, take note, in both organic and inorganic samples. Okay? And in addition to Kjeldahl method, it is named after Johann Kjeldahl. So, Johann, Johan, Kjeldahl. Okay? But today, no, nowadays, it is not routinely used in clinical laboratory or laboratories because it is time-consuming and tedious, no? Pagka ginawa natin. So, matrabaho po siya. An average of, just take note, no, for Kjeldahl, an average of 16% nitrogen mass in protein is assumed to calculate the protein concentration. And the actual nitrogen content, which is 15.1% and 16.8%, or to 16, to 16.8%. So, errors, no, may introduce in Kjeldahl method. So, lalo na kapag po ang gamit nating protein standard, no, can differ from the serum specimen na i-analyze po natin. So, magkakaroon siya ng mga interferences. So, serum proteins precipitated with an organic acid. So, yung organic acid na ginagamit natin for Keldal, we have the TCA or tungstic acid. Okay? So, yung TCA po, trichloroacetic acid. So, take note. TCA, trichloroacetic acid or tungstic acid. So, the protein pellets is digested in H2SO4. So, ang H2SO4 natin ay sulfuric acid with heat, no, na merong temperature of 340 to 360. So, sabi ko kanina, yung protein pellets, no, is digested in H2SO4 with heat. So, yung mga protein pellets naman natin, no, it refers to the solid or pellet-like material formed when proteins are precipitated or separated from a solution. Okay, again, protein pellets refers to the solid or pellet-like material formed when proteins are precipitated or separated from a solution. Okay? And as a catalyst, no, in this or in the reaction, we use cupric sulfate. Okay? So, si potassium sulfate, ginagamit din siya to increase the boiling point in Keldal method. Okay? So, take note ha, si catalyst, we use cupric sulfate and to increase the boiling point, no, para sa Keldal method, gumagamit tayo ng potassium sulfate. So, the H2SO4 or sulfuric acid oxidizes the carbon, hydrogen, and sulfur, okay, into carbon dioxide, CO2, carbon monoxide, H2O, and sulfur dioxide. Okay? So, the nitrogen in the protein is converted into ammonium bisulfate, which is measured by adding alkali and distilling ammonia into boric acid. And of course, no, after this method, ammonium borate is formed with or using titrated sample with standard solution of HCl to determine the amount of nitrogen in the original protein solution. Okay, so titrated with HCl. Okay, next method, we have refractometry. So, itong refractometry na encounter nyo na yan, no, sa inyong, lalo na sa inyong CM. No? So, sa mga nakahawak na ng refractometer, maliit lang naman yan na device, no? So, it is used when a rapid and easy method, no, and requires a small amount or small volume of serum. So, the principle, no, of refractometry, take note, measurement of refractive index due to solutes in serum. So, yan yung kanyang principle, no? And non-protein solids are present in same concentration as in the calibrating serum. So, yung mga non-protein solids natin, yun yung mga electrolytes, urea, and even glucose, no? So, these non-protein solids contribute to the refractive index of the serum. Okay? So, yung ating mga protein refractometers, so, meron siyang sample stage kung dun yun nilalagay yung ating serum, of course, and the detector. Yan. So, ayan. Again, yung mga non-protein solids natin, electrolytes, urea, and the glucose. So, error is introduced when these substances are increased or when the sample is ecteric lipemic or hemolyzed. So, yung lipemic sample tsaka hemolyzed na sabi na natin kanina, na-mention na natin. So, how about the ecteric sample? So, ano naman pong itsura ng ecteric sample? So, pagka sinabi nating ecteric, no? With the presence of jaundice, okay, kung may jaundice po yung ating patient, yung sample na ma-obtain natin sa kanya ay posible, no, na color yellow yung kanyang sample. Okay, so yellowish yung color, no, kapag ecteric. Due to, sabi ko kanina, due to jaundice. Okay? Next, refractive index is temperature dependent. So, meron siyang built-in temperature correction, no? Si refractometer. So, next method, we have the Biuret. So, this is the most widely used method and the one, no, that is recommended by the International Federation of Clinical Chemistry. So, si International Federation of Clinical Chemistry, sila yung nagbibigay sa atin ng mga guidelines, no? With the determination ng mga lab request na ginagawa natin. So, parang sila yung nagbibigay ng mga references, no, na susundin natin, guidelines. Okay? So, in Biuret method, no, the cupric ions, ayan, complex with the groups involved in the peptide bond. In alkaline medium, no, in the presence of two peptide bonds. So, pagka sinabi natin two peptide bonds, yung dalawang amino acid, so they are linked together in a protein, okay, or peptide chain. Okay? And a violet-colored chelate is formed. Okay? So, yung colored chelate natin, it refers to a complex formed between a metal ion and a chelating ligand. Okay? So, yung ating chelating ligand, yun yung nagsastabilize ng mga metal ions. Okay? So, the reagent, no, used in Biuret method or Biuret method, so we used sodium potassium tartrate, so this reagent, no, is used to complex the cupric ions to prevent the precipitation. Okay? And we also use potassium iodide, which acts naman as the antioxidant. So, the absorbance of the colored chelate formed is measured at 540 nanometer. So, the end color for Biuret method is pink to reddish violet. So, tulad lang din sa ibang diniscuss natin before, like colle and glucose, no? Yung mga colors po, mga end colors ng ating sample or product, no? Nagva-vary yan depending dun sa concentration, level of concentration ng like yan nga, protein sa ating bloodstream, no? Dun sa sample natin. So, sa Biuret, pink to reddish violet yung kanyang color variation. Okay? Next, for dye binding. So, these methods are based on the ability of most proteins in serum to bind dyes. So, we use bromoquinol blue, Poncho S, Amido Black 10B, Glycerin green, Coamasy brilliant blue to stain the proteins. Okay? Again, bromoquinol blue, Poncho S, Amido Black 10B, Glycerin green, Coamasy brilliant blue. Okay? So, the Coamasy brilliant blue 250, no? Siya yung pinakang common. This Coamasy brilliant blue 250 relies on the binding of CBB or the Coamasy brilliant blue 250 to protein, causing a shift, okay, in absorbance maximum dye from 465 to 595 nanometer. So the increase in absorbance at 595, it is used to determine the protein concentration. Okay? Next, for fractionation, identification, and quantitation of specific proteins. Right? So we have salt fractionation, determination of albumin and total globulins, and also electrophoresis. So yan yung mga ginagamit nating methods to quantify specific proteins. So first, for salt fractionation, okay? So this is done using precipitation, okay? And globulins are separated from albumin by salting out. So pag sinabi natin salting out, the process of salting out involves the adding of high concentration, okay, of salt to a solution. Okay? Again, for salting out, the process involves adding a high concentration of salt to a solution which causes the target molecules to precipitate. Okay? So the albumin that remains in solution in the supernatant is measured. Maisingit ko lang, last time dun sa ating activity, may mga nalito pala regarding dun sa ating supernatant, So, si supernatant, guys, huwag niyong kakalimutan, na pagka ang inyong solution po ay nag-separate siya, so, ang supernatant, syempre, yung nandun po sa upper portion, yung liquid portion. So, yung matitira po, yun po yung ating precipitate. Naintindihan? So, nagkalituhan po pala last time, So, si supernatant, it's always the liquid portion kapag ka separate tayo or centrifuge ng isang solution, So, yung may iwan, yun po yung precipitate. Okay? So, para lang maalala po ninyo, So, again, albumin that remains in the solution in the supernatant is measured. But this salt fractionation is not used today because direct methods are available. Okay? For the determination of albumin, so most widely used methods for determining albumin are dye binding procedures. So the pH of the solution is adjusted so that albumin will become positively charged. Okay? So the albumin is attracted to or bind to an anionic dye by electrostatic forces. Okay? So the amount of albumin is calculated by measurement of the absorbance of the albumin dye complex, and a variety of dyes, of course, have been used for determination of albumin. So we have methyl orange, 2,4-hydroxyazobenzene benzoic acid or HABA, and bromocresol green and bromocresol purple. Okay? But take note, methyl orange is non-specific for albumin. So, bakit? Kasi nagbabind din kay methyl orange si beta-lipoproteins. Take note for methyl orange, nagbabind din sa kanya si beta-lipoproteins, alpha-1, alpha-2 globulins. Yun, so yung tatlo, Kaya si methyl orange ay hindi daw siya specific lang for albumin. So, beta-lipoproteins, alpha-1 and alpha-2 globulins will also bind to methyl orange. For total globulins, So, this is another approach to fractionation of proteins, So, yung pagde-determine natin ng total globulins. So, the total globulin level in serum is determined by a direct colorimetric method using glyoxylic acid. So, glyoxylic acid, in the presence of cupric ions, in an acid medium condenses with tryptophan, which results, no, to a purple color. So, ano ba yung mga acid medium na ginagamit natin for determination of total globulins? So, we have acetic acid and H2SO4 or yung ating sulfuric acid. So, huwag kakalimutan, no? Ang end color naman for this one is the purple color. And take note, no, albumin has approximately 0.2% tryptophan, okay, compared with 2% to 3% for the serum globulins. Okay? So, this tryptophan, no, is an essential amino acid na hindi siya nasi-synthesize or cannot be synthesized by the human body. So, saan natin siya ma-obtain? Through diet. Okay, again, for tryptophan, so this is an essential amino acid which are not synthesized by the human body. So, para ma-obtain natin siya, no, is through our diet or intake, no, dietary intake. Next, for electrophoresis. So, ginagamit natin si electrophoresis, no, when an abnormality is found in the total protein or albumin. Okay, so piniperform natin tong electrophoresis. So, in here, it separates proteins based on their electric charge densities. And protein, no, when placed in an electric current, syempre, the direction of movement depends on whether the charge is positive or the charge is positive or negative. So, the specific electrophoretic mobility is calculated by, so this one, pag malilito, with regards to electrophoresis, ayan po ang symbol ng electrophoretic mobility. Okay? For S, ito, it means, it is the distance traveled. Ang unit po natin dito ay cm. cm. Okay? Tindihin nyo na lang, no? Over T. So, yung T meaning time of migration. So, ang unit po natin sa T ay seconds. Seconds. Over F. So, F meaning it is the field strength. Ang kaniyang unit ay V cm negative 1. So, just take note lang, no? Hindi naman natin to ginagamit manually or kinukompute manually, no? So, just to have an idea lang, so yan po yung ating formula for electrophoretic mobility. So, in addition, the electrophoretic mobility, no, is we use this to measure how quickly charged particles, okay, charged particles such as ions or molecules move in an electric field. Okay? So, this electrophoretic mobility is a critical parameter in techniques like gel electrophoresis and capillary electrophoresis. No? So, it is used to separate and analyze molecules based on their size and charge. So, as a support media, no, we use cellulose acetate or agarose gel. So, electrophoresis using an aqueous medium. So, tinatawag natin din siyang moving boundary electrophoresis. Kapag aqueous yung ating medium na ginamit. Pagka solid naman, which is paper, no? Paper medium, ang tawag naman po natin doon ay zone electrophoresis. So, malilito for aqueous medium, moving boundary electrophoresis, and for solid medium, we call it zone electrophoresis. Next, serum protein excuse me, phoresis. So, this test, no, is used to separate and quantify the proteins in a sample of blood, which is serum, no? And the test is primarily used to identify and characterize abnormalities in the concentration of different protein fractions. So, a blood sample is collected from patient and of course, no, yung ating sample is serum. So, this is loaded onto a gel or cellulose acetate strip. And as a result, no, the proteins separate into distinct bands or zones based on their, syempre, pagka sinabi natin electrophoresis, no, it's always based on their charge and size. So, the gel or strip is stained with a dye or protein-specific stain to visualize the separated protein fractions. So, these protein fractions include albumin, alpha-1 globulins, alpha-2 globulins, beta globulins, and gamma globulins. Okay? So, the amount of each protein fraction is determined by measuring the density or intensity of the bands or on the gel or strip. So, the quantitation, no, is typically reported as percentage of the total protein or as grams per deciliter, okay, of blood. And take note, no, albumin is the primary protein fraction found in the blood. Again, albumin is the primary protein fraction found in the blood. So, alpha-1, alpha-2, and gamma globulin fractions, no, represent various other proteins including immunoglobulins, acute phase proteins, and the enzymes. So, the abnormal patterns or levels of these protein fractions can indicate various medical conditions such as liver disease, kidney disease, inflammatory disorders, multiple myeloma, and other malignancies. So, this is an example of serum protein electrophoretic patterns, no? So, itong letter A is for agarose, no? Yung ating medium na ginamit, agarose. And for letter B, cellulose acetate. Cellulose acetate. So, we have here the selected densitometric patterns of protein electrophoresis. No? So, arrows, kung makikita nyo po, no, arrows indicate the decrease or increase in fractions. Okay? So, in here, no, yung una po natin, walang letter. Yan, yung ating reference pattern. So, ito po, ginamit nating medium, dyan ay agarose. For letter B, yung ating monoclonal increase. So, ganyan yung kanyang pattern. So, monoclonal increase in gamma area, we used agarose. No? For letter C, the alpha-1 antitrypsin deficiency. So, yan yung kanyang pattern. Take note in cellulose acetate. For nephrotic syndrome, yan yung letter D. In cellulose acetate also. Next, yung ating inflammation. So, ganyan ang kanyang electrophoretic pattern. No? Also in cellulose acetate. And for cirrhosis, no, cellulose acetate din yung gamit nating medium. For HRE, or high resolution protein electrophoresis, So this is an advanced and more precise version of traditional serum protein electrophoresis. So in here, it is used to separate and analyze the various protein fractions in a blood serum sample with greater accuracy and details. No? So we have here the key features or yung mga benefits na sa paggamit no, ng HRE. So it improves separation of protein fractions. It enhances detection of abnormalities and subtyping immunoglobulins, and it provides precise quantification of individual protein fractions, which can aid in monitoring disease progression and assessing treatment effectiveness. Okay? It also provides additional information about protein subtypes and other protein abnormalities that can be crucial in diagnosing and managing specific medical conditions. So this HRE is commonly used in hematology, oncology, immunology to assist in the diagnosis and monitoring of conditions such as multiple myeloma, lymphoproliferative disorders, and various autoimmune diseases. Next, we have the capillary electrophoresis. So this is a versatile analytical technique used in chemistry and biochemistry to separate and analyze wide range of molecules. So movement of charged particles in an electric field through a conductive medium, typically within a narrow capillary tube. No? So in capillary electrophoresis, the separation occurs within a very narrow capillary tube, which typically made of fused silica. Okay? And for kinetic, electrokinetic mobility, analytes in the sample carry a net charge and they move through the capillary under the influence of an electric field. So, capillary electrophoresis can employ different separation mechanisms, including, okay, take note, including capillary zone electrophoresis and micellar electrokinetic chromatography. So, wait lang guys, wait lang.
Kaya nga, hindi pala sila nag-ano. Pero piling ko mga 5 nandun na yun. Malapit-lapit na yan.
Yan.
Suka ko.
So, ulitin natin. Capillary electrophoresis can employ different separation mechanisms, including capillary zone electrophoresis or CZE and micellar electrokinetic chromatography. Micellar, M-I-C-E-L-L, wala dyan L-L-A-R, wala. Electrokinetic chromatography. Okay? So, capillary electrophoresis has a wide range of applications, including applications in various fields, including pharmaceuticals for drug analysis, for environmental analysis, in monitoring water quality, for forensics. It is also applied for DNA analysis and biochemistry for protein and nucleic acid analysis. Okay? So, capillary electrophoresis systems can be highly automated, allowing for high throughput analysis. So, additionally, capillary electrophoresis small-scale nature makes it suitable for analyzing limited sample volumes. So, meron tayong ginagamit na different detectors, no, in CE. So, we have UV-Vis spectrophotometers. We also use fluorescence detectors and mass spectrometers. So, CE is widely used in DNA sequencing techniques. So, for example, sa ating DNA sequencing is yung Sanger sequencing technique, no? So, this is an example of DNA sequencing technique. Next, isoelectric focusing. So, this is used to separate and analyze proteins, peptides, and other biomolecules based on their isoelectric points. So, yung unit natin for isoelectric points is ito, yung PL. So, yan yung ating symbol, no, for isoelectric points. pH at which a molecule carries no net electrical charge and remains stationary in an electric field. So, isoelectric focusing relies on the principle that charged molecules will migrate to to their isoelectric point when placed in an electric field within a pH gradient. So, the sample to be separated must be in a solution with a pH gradient. So, the pH gradient should cover the expected isoelectric point range of the analytes. So, in here, the sample is loaded onto a gel or capillary tube containing the pH gradient, and an electric field is applied across the gel. So, the molecules with an isoelectric point, no, higher than the pH at the cathode will migrate towards, of course, the cathode, and those with a isoelectric point lower, okay, ayan na, higher, and then lower than the pH at the anode will migrate towards the anode. Tandaan nyo lang naman po yan. So, as the molecules move through the pH gradient, they reach a pH where they carry no net charge. So, they stop migrating and form a sharp band or zone. So, in this separation is based on the molecules' intrinsic properties as they are separated according to their isoelectric point values. So, molecules can be visualized using various methods such as staining with Comasy blue or silver staining, or through downstream analysis techniques like mass spectrometry. So, isoelectric focusing is commonly used for separating and purifying proteins, and it is used in clinical laboratories to analyze proteins in the body fluids like serum, urine, and even sa CSF, no? Pwede nating ma-measure yung ating protein levels. So, isoelectric focusing is employed in biotechnology for the production and characterization of recombinant proteins, as well as in biopharmaceutical quality control. So, this is used for DNA sequencing, especially in the older but still, no, valuable Sanger sequencing method. So, Sanger pa din yung ating ginagamit for DNA sequencing method. So, this is used to analyze proteins in food and beverages such as milk proteins and gluten in wheat. So, I'm still referring to isoelectric focusing. For immunochemical methods, so ito medyo familiar na kayo, no? For ELISA, so the enzyme link immunosorbent assay. So, this is the most common immunochemical methods for protein detection. We also use Western blotting or immunoblotting. So proteins are separated by electrophoresis, transferred to a membrane, and then probed with specific antibodies. For immunoprecipitation, it isolates and purifies specific proteins or protein complexes from a mixture. And for immunohistochemistry, it's employed to visualize the location and relative abundance of specific proteins within tissue sections. So, meron na din ba kayong, ma-encounter nyo rin to sa inyong histopath, no? Kung meron na kayong histopath. For immunofluorescence, visualize proteins in cells or tissues using fluorescently labeled antibodies. And for RIA, the radioimmunoassay, it measures the concentration of specific antigens such as the hormones or proteins using radioactive labeled antibodies and antigens. For proximity ligation assay, it detects the protein-protein interactions or the presence of specific proteins by using pairs of antibodies labeled with complementary DNA strands. Next, for immunoelectrophoresis, combines electrophoresis and immunodiffusion, okay, to separate and identify proteins based on antigen-antibody interactions. And for biomarker panels and multiplex assays, it involves multiplex assays allowing the simultaneous detection of multiple proteins. So, this is this is a summary, no, ng mga ginagamit nating methods for protein determination. Familiarize nyo. Yung nandyan sa table. For proteins in the other body fluids, nabanggit natin kanina, no? We have protein also in our urine. Okay? So, we can also detect protein concentration sa ating urine. So, urinary proteins found in the urine are from the blood, which can originate from the kidney and urinary tract. And plasma proteins appear in the urinary or in the urine. Okay? So, in here, the plasma proteins appear, no, in the urine because they have passed through the renal glomerulus. So, kung na-encounter nyo na sa inyong CM, they have passed through the renal glomerulus and have not been, okay, reabsorbed by the renal tubules. Okay? So, dun siya nagre-reflect or nagmamanifest, no, sa ating urine. And the qualitative test, take note, reagent strip, no, as qualitative test for proteinuria are commonly performed in the laboratory. So, reagents test strip, take note, qualitative test for proteinuria. So, these methods are based on the change of an indicator dye in the presence of protein known as the protein error of indicators. Okay? So, this is the ability of protein to alter the color of some acid-base indicators without altering the pH. So, yellow color. So, absence of protein, no, concentration. And for green to blue, depending, no, on the level of concentration. So, nag-vary yung color niya from green to blue. So protein concentration with 6 milligrams per dl or greater produces a color change. And for quantitative assays, no, ang ginagamit po nating urine specimen is a 12 or 24-hour urine specimen. So, the most common or ang common na ginagamit natin in the laboratory is the 24-hour urine. Okay? So, this 24-hour timing allows for circadian rhythmic changes. So, kung narinig nyo na po ito, no, yung circadian rhythmic changes, it refers to the natural and internal rhythms, no, over a 24-hour cycle. So, di ba ang ibig sabihin ng circa is a cycle? So, over 24-hour cycle. So, the results are reported generally in terms of weight of protein per 24 hours. Okay? So, we have here the several precipitation methods for the determination of total proteins in the urine, no? So, we uses sulfosalicylic acid, TCA, or trichloroacetic acid, benzethonium chloride. So, these tests are sensitive, no, for protein determination. And take note, for sulfosalicylic acid, kung ito po yung gagamitin natin, it produces 4 times turbidity with albumin, okay, than alpha globulin. So, mas turbid, no? 4 times turbid si kapag ka-present po yung ating albumin in sulfosalicylic acid. So, precipitation of the urine proteins, dissolution of the protein precipitate, and color formation with Biuret reagent, so as quantitative methods. Yan. Follin, so culture reagent, or ang content niya is yung ating phosphotungstomolybdic acid solution or phenol reagent. So, ang kaniyang color variation is yellow, from yellow to blue. So, this is due to the tyrosine, tryptophan, histidine residues in protein. So, dye-binding methods, we have Comaciblupaden and Poncho S. So, they are insensitive for urine microalbumin testing. So, hindi niya na-detect, no, yung mga microalbumin. So, the reference interval for urinary protein is 100 to 250 milligrams. So, kung ang sample natin po ay 24-hour urine sample, no? So, 100 to 250 milligrams per 24 hours. So, accepted pa. Next, nabanggit din natin kanina, no? Yung ating CSF proteins, no? Cerebrospinal fluid proteins. So, this is formed in the choroid plexus of the ventricles of the brain by ultrafiltration of the blood plasma. And protein measurement is one test that usually requested on CSF. So, 10 to 40 years old, ang accepted value po for CSF protein is 15 to 45 milligrams per dl. Abnormally increased ang ating CSF proteins in bacterial, viral, and fungal meningitis, traumatic TAP, multiple sclerosis, obstruction, neoplasm, disc herniation, and cerebral infarction. Okay, so abnormally increased. The degree of permeability can be evaluated by measuring CSF albumin and serum albumin. So, the albumin is usually used as the reference protein for permeability because it is not synthesized to any degree in the nervous system. The reference value for CSF albumin to serum albumin ratio, no, is 2.7 to 7.3. So, value greater than this indicates that the increase, the CSF albumin came from plasma due to damage of blood-brain barrier. So, last slide, no? Low CSF protein values can be seen in hyperthyroidism, and chemical or spectrophotometric methods are also used. And for turbidimetric, no, ang methods, ang ginagamit po natin ay TCA, trichloroacetic acid, sulfosalicylic acid with sodium sulfate, and benzethonium chloride. And for dye-binding methods, Comacib brilliant glupaden, we also use kinetic Biuret reaction and the Lowry method or Follin phenol reagent. Okay? Yan. So, I think that would be the last slide, no? For protein determination. Ayan. And nasend ko naman na din to, no, sa ating channel. So, pwede niyo pong balikan. Okay? So, next meeting, yun lang, di natin siya magagawa as like dun sa ating chole and glucose, no? So, proceed na tayo sa ating electrolytes next meeting. So, huwag kakalimutan po magdala ng blood collection materials. Okay? So, ano pa? Attendance ulit tayo bago mag-end yung para lang may copy ako kung sino yung umattend from the very beginning, no? So, pa-open lang po ulit